So this was the homework assignment that you guys had over um, last week. Reason I have it up is because there was just a common mistake. I would say about 80, maybe even more, 80% or higher. People did the same thing for number 13. I think a lot of people thought 13 was a lot easier than it actually was. So for anyone, I did a lot of them this morning. So if you had a chance to look at them, that's great. If you didn't have a chance to look at it, if you handed in early, you might have been able to see it. But like I said, a lot of people did this incorrectly because they just assumed. Let me just find the degree measure. The directions do say arc length, and that word length really throws a loop at you that you really need to pay attention to that wording because it's not like 11 where and this is where like that little m in front of it. Sometimes we kind of usually ignore it, but that little m means the measure of arc JK, which is usually the degree measure of something. And that's why it says find each measure. So degree measure is different from length measure. So that's a little kind of sneaky thing they could do with the notation, but they absolutely put in the directions with the wording as well. So 11, you had to put the degree measure, which I think most people did just fine. But whatever. But because of arc length, and I think everyone found the degree measure just fine. I forget what it was off the top of my head, and everyone who found the degree measure did it fine. I think it was like 55 and something else. But after you find the degree measure, you need to use this formula, which we spent about a day or two using, the percentage of that circumference. So that's where this number would go. I think for A it was 55. You'd put 55 over 360 times 2 pi r. Yeah, like I said, I've been grading these with leniency, so I grade them more like an actual homework, where if you got 13 wrong, if you did that mistake and that was your only mistake, you still got a perfect score, which this assignment was out of 16, which is equivalent to 4 homework assignments. So the results on this assignment were still very good, 14s, 15s, and 16s for, I would say, the majority of people who handed it in, which is really good. But take a look at the comments. Also, on some people, for some people, especially if I graded yours earlier on, I screwed up. Some people I marked it correct and it was actually wrong. I think the answer is 136. And then some people who put the right answer I actually marked wrong. At least like the first 5 or 6 assignments that I graded, I definitely marked it wrong. And I guess that's the bad thing about grading them online. I couldn't really go back and fix that mistake. But it says US, and a lot of people did US going this way, which you even fooled me, because that's the major arc, and because it's only 2 letters, you have to assume it's the minor arc, which would be this one right here. So just double check that, especially if you handed it in early. If you know you handed it in earlier in the week, just double check that. I think the answer was 136. And majority of people did hand this in, which is really good. But for those of you who did not hand it in, like I said, the most important thing, especially that we're learning this stuff remotely, is hand in your assignments. You're very likely to pass this class. If you just hand in your assignments, you are here and participating. A lot of people message me, reasons why they were going to be late, and that's fine. I'm not being super strict with late work. Especially, if you get it in over the weekend, that's probably fine. But if at a point where I've graded them all and then you've handed it in, it's probably when I'll start taking off late points. I'm trying to be as lenient as possible, as understanding as possible, and so forth. I hand that in, and that would be much appreciated. But if there's any questions, feel free to send me something on Remind or something like that. And I think that leaves us with tangents. And before I jump into... we actually finished tangents. That's good. So before I jump into that, I got a few more things I kind of want to just announce. We'll do another assignment this week. I think this week will be a weekly. We had one 2 weeks ago, so we'll do another weekly. I'll put a weekly on Google Classroom, probably after this stream or after my physics stream, but it'll go up tonight. You'll probably have weekly 29 or 30. I'll take a look at it and see which one I think is maybe more relevant to us. Hopefully there maybe some circle stuff on there. So that'll be this week's assignment. Same idea. I'll put it up today. It'll be due Friday. Best thing you can do, hop in tomorrow, Wednesday, ask me questions on it. Like always, I'll go through the solutions or, guide us, and so forth. But that's obviously not up right now. I do want to just go over, before we kind of jump in to what we're going to be doing today, and kind of this week, is I want to go over some of the rules we have covered so far. Like I said, with circles, there's so much stuff with circles. Every day it's just one new thing with circles, where, when we did triangles, it was just, we had an entire unit on like one thing. Circles, it's just one thing after the next, and maybe you don't realize it, but we've done a lot so far with circles. So we've done area and circumference. So this is just a little kind of review on what we've done so far, which is pi r squared and circumference. Oops, I put 2 pi pi. It's 2 pi r. So that's one thing that we did. We did central angles. Which central angles come from the center of the circle, and they are always the same degree measure, so 40 degrees, 40 degrees. I'm just kind of arbitrarily using numbers here. We talked about arc length. We just covered that from the homework. Which is percentage of the circle times 2 pi r, the circumference of the circle. And that tied in with central angles because that is likely where you got that value of x. X was the arc measure. Then we did inscribed angles. Which came from the edge of the circle. And they were half the length. Meaning if this were 80 degrees, this would be 40 degrees. And then we also had a special rule with inscribed angles, whereas if I had a circle with a diameter, oh, that's a bad diameter, that's fine, and it comes from here to here, that makes this a 90-degree angle. I bring that up because that comes up very frequently. That's a very important rule right there with inscribed angles, because this is a semicircle. We did congruent chords, which create congruent arcs. So congruent chords, if this were congruent and this chord were congruent, that makes these outside arcs congruent. They're also equal distance from the center, which means the perpendicular lines extending from the center would also be congruent in length. So congruent chords, they're pretty self-explanatory. There's a lot of symmetry that goes along with congruent chords. And then I think the last thing we did, there might have been more, but we also, on Friday, we covered tangents. But I think this is everything we've covered up to this point. And the most important thing with tangents, there's actually a few things with tangents. Number one, the most important is a radius that connects to a tangent forms right angles. That's the most important rule. Another important rule is if they come from the same external point, those line segments would be congruent to each other. If you think there's a rule I'm overlooking that we covered that I just forgot to mention, just let me know. I can check through the notes really quick to just make sure I haven't missed anything. But I think that is everything we've covered so far in this unit, which is that's quite a bit. Area and circumference, I know you're familiar with from probably 8th grade or even younger, but all the other stuff is probably new. So that's a lot of new stuff to be thrown at you kind of each and every day. So I think it's a nice little recap on what we've done. Because what we're going to get into this week, it's going to be a little bit more rapid fire. It's going to be a lot of new rules. And we're going to practice some algebra today. That's going to get into that stuff. Because you'll notice the next thing in your packet is this right here. Just some practice with algebra. So we are going to see a little bit more quadratics, and we're going to see a little bit more setup. This is probably the most challenging algebra we could see, at least in geometry. It's still easier than the algebra you've done last year. That I can't make that any clearer. It's just there are going to be multiple step equations. There's very good chances we could run into quadratics. We could be expanding or foiling binomials and stuff like that. And then we're going to have to practice completing the square, which is a technique you used last year. It's a technique of factoring. That's probably going to be a little bit towards the later end of the unit, though. So you might recognize that name, completing the square, and you might wonder, what does completing the square have to do with circles? We'll get into that. So I think there's a few things that we want to practice with algebra. So we're going to do this section because, like I said, you're going to get a ton more rules, probably starting tomorrow. That's one right there. Then there's 3 right at the top of this page. And then I think we do some practice with that. And then there's just another 3 that come up. So there's a lot yet. There's another 3 right there. And these rules, I find that students, they struggle with. They're not hard. There's just so many of them they forget which one to do when and so forth. So I want to spend as much time as possible. That's likely what we're going to be planning throughout the week with circles, because it is a lot. So if there's any questions on kind of anything I've just said and kind of what the future looks like, at least for this week, just let me know. Alright, I'm not seeing anything, so I guess that's good news. Hopefully then all those messages were clear. I know that's a lot of announcements, kind of to start off our week, but we'll jump right into it. We're going to just practice some algebra. So some of our multi-step equations. This one, not too bad. We're going to be doing a lot more distribution. In this case, we're going to distribute this 8 across, and we're going to distribute this 2 across. So we're going to have 8x minus 40 equals 6x minus 16. We're going to add 40, subtract 6x from both sides. Hopefully you're okay with me doing 2 things at once, doing the x's and whole numbers simultaneously. We get 2x equals, what was this, 24? And then we can divide both sides by 2, and we get x equals 12. So really just distribution, kind of the most important thing we can see there. Number 2. Oh. Still unsure why that happens. Should be back up. Now with this one, the only thing that's slightly more challenging that some students might forget is you have a negative in front of parentheses with no number here, but we are to assume that there is a 1 in front of there, so you do need to distribute a negative 1 across both, because a lot of students will just drop the parentheses thinking, oh, those parentheses aren't important. But when there's a negative in front of parentheses, it is very important. You are distributing a negative. So that 7 is going to continue to stay negative, but that positive 3 is also going to become a negative. So it's 167 minus 7x minus 3 equals 108. So you'll notice, especially from here to here, the sign has flipped. As it has also here, because technically that 7 inside the parentheses is positive. So whenever you see just a lone negative in front of parentheses, don't forget that rule of distributing the negative across. Technically, you're distributing a negative 1. And then you could solve from here. You can combine like terms as well. So you can do this and this to get 164. So it's negative 7x plus 164 equals 108. So now when you subtract both sides by 164, you get negative 7x. You are going to get a negative now. You have positive 108 minus 164. So you are going to get a negative number here, which we get 56. Negative 56. So now when we divide both sides by a negative, it will flip to a positive, which we haven't really seen a lot this year. We really don't have to deal with these double negatives. But definitely something we can look out for. Hopefully good refresher from last year. Negative 56 over negative 7. It's going to be positive. That's an 8. Because don't forget, you can get negative x values. Even in geometry, sometimes we have a confusion on, negative x values can't be in geometry. They can be, just so long when you plug into your geometric figure, you don't get any negative sides or angles. That's where you can't have negatives. But some x values can be negative. It just has to fit the diagram if you were to plug back in. But we do get a positive x here, so that really doesn't matter. And then this is really good to practice because we're going to see this a lot when something is divided by 2. You have a lot going on the top, and then something is divided by 2, and then equals some number. So we're specifically practicing this right here because one of the rules is kind of replicate what this looks like. And there's a few ways you can do it. I think the easiest way is you're going to throw the 47 over 1 and cross multiply. I think that is the easiest way to deal with this, because this whole numerator crosses into the 1, and we know anything multiplied by 1 is just going to stay the same. And then when you cross multiply the other side, 47 and 2. That way you get rid of all the fractions and so forth. So you're left with 3x plus 15. And then as I look right here, I see a positive in front of parentheses. You don't need to distribute. I mean, technically you are distributing, but this is a case where you can drop parentheses because there's a positive in front of there. So it's positive 11x minus 5 equals, cross multiply the other side, and we get 47 times 2, which is 94. Combine like terms. Subtract both sides by 10. We get 14x equals 84. And then from there, we get 6. Good. I'm glad you think this is a good refresher. That makes me happy. Because like I said, we're going to see all this kind of algebra skills in circles. I know we're not doing any geometry right now. We're just kind of reviewing something. And then the very last one kind of combines everything that we have. You have lots of expressions, lots of things going on here. We're still going to cross multiply, so I'm going to put this over 1, which makes... Now, we've seen this before, but you have 2x minus 7 times 2, and there's no parentheses around here, but technically, if you're putting it over 1, it is technically in parentheses. It is an expression. So you will need to distribute this 2 when you cross multiply. As you know, you got to multiply everything by 2. We didn't have to do that with this one because it was just a whole number. It was just 47 and the 2. But this one is 2x minus 7, and it's an expression. multiplied into 2. So we will have to multiply both sides by 2. So that's going to be 4x minus 14 equals, and then, well, this is just multiplied by 1, so there's really nothing to worry about there, because anything multiplied by 1 is nice and easy. However, the one thing that is different is the sign in front of the parentheses is negative. So I am going to distribute that so I can drop the parentheses. So it is going to be negative 3x, and then it's a negative into a negative 14. So that is going to flip it to a positive 14. So you still have 8x minus 47. There was nothing going on with those two. But these, now I'm going to drop those parentheses and distribute that negative across. Oh, so many algebra fans out there. And then we have to combine like terms and so forth. So sometimes I like to just figure out where it's going to be easiest to kind of, where should I put my x terms? I'm just going to combine like terms and see kind of what happens. So combine these, combine these. Left-hand side looks fine, so it's going to be 4x minus 14. Combine my x's, I get 5x. Combine my non-x terms, that's going to be negative, because the 47 is bigger, so it's negative 33. And in this case, I think putting x on the right-hand side is just going to make a little bit more sense to me, because that way the x is positive. I know a lot of people kind of force x to be on the left-hand side, which is, it's fine, it's going to work, but if I can avoid negative numbers, I might as well. And then that would mean, since I'm putting x on the right-hand side, I'm going to put the 33 on the left-hand side. So I do get negative 14 plus 33, which I think is 19, positive, equals 5x minus 4x, which is just 1x. So that gets me to my final answer. And that's as complicated as the algebra is going to be in that case, at least with multi-step equations, non-quadratics. Because like I said, we might see some quadratics where we have to factor and so forth. It is possible we could run into quadratic formulas as well. The next algebraic skill, very important, and I think it's a good review to go over this anyway. I mean, anyone who's moving on to Algebra 2 next year, you're going to need all these skills anyway, so I think it's a good refresher to kind of go over them, because you're going to see this stuff a bunch. Now, I know last year, for all of you who had Mrs. Keener, that she does not refer to this as foiling, and I do. I think you guys just call it the box method. I call it FOIL. Just know they're the same exact thing. It is pretty universally known as foiling. If you go to another school and you ask a student to FOIL this, they'll probably know what you mean. You guys just know it as the box method, which I think you guys you did this. You put an x and 8 over here, an x and negative 1 over here, and then you would do your multiplications. I guess that's a plus, right? Yeah, plus 8. So x squared. Then you have 8 times x, so that becomes 8x. Then you have x and negative 1, which would be negative x. And then 8 and negative 1, which would be negative 8. And typically you can combine one of them, well, I guess two of them, which are usually these two right here that could be combined to write out the entire expression, which is x squared. Then you have 8x minus x, which would be plus 7x minus 8. That's it. And that's just expanding it out, foiling, really whatever you want to call it. The reason why it's called FOIL, by the way, it's an acronym. It stands for first, outer, inner, last, and all it does, it's the same thing. That's your first, the first part of your box method. Then the outer is the outer numbers, so it would be x and negative 1, which is also in the chart, and then inner which would be 8 and x, and then last 8 and negative 1. Just multiplying them all, writing them out. So it's the same exact thing. I mean, just that's where the name FOIL comes from when you're multiplying binomials. However you want to do it, the box method is just a little bit more writing, but it doesn't matter to me. Use whatever you think is going to get you to that right answer. But just note, I'm probably not going to be doing the box method. I'll just be doing it like this. 3x times x, which I know is 3x squared. Just be careful, some people will multiply these together and call it 4x, but that would be addition. We are multiplying. So it's 3x times x, then 3x times 6, which would be 15x. Then my inner, which is negative 5 times x, so it's negative 5x, and then negative 5 times 6, which is negative 30. And then in this case, those two middle terms can combine because they are like terms, so you can do plus 15x minus 5x. You'll see I have 4 terms, just like you would in a box method. Then I combine them, plus 10x minus 30. If that way is far too confusing for you, then use the box method. Please let me know too. I don't know if anyone finds that confusing or that they need the box method. I don't know. Just let me know. I'll use that method. It's 18, not 15. How did I get 15x? Oh, it should be 18x. Yeah, it should be 18. It's because my mental math is off. One of these days I'll go a full stream without making a mental math error. So I would change it to 13. Thank you. Double check that. Is that better? I think so, right? Yeah, it looks good. Thank you for catching that. Now we'll keep on going. Then we have 2x minus 7 and 5x minus 2. We're going to do the same thing. Sometimes writing out the whole box can really help. Then you definitely do that if that helps you. So we got 2x and 5x. So you do have coefficients in front of it. So you do 2 times 2, which is 10. X times x, which is x squared. And then you can move on to the next term. 2x and negative 2, which is minus 4x. The inner, negative 7 and positive 5. So don't forget this negative does matter because it is a negative 7. So it's going to be negative 35x. And then negative 7 into negative 2. So a negative into a negative, you do have to consider these things. So that becomes a positive 14. And then like always, those middle terms typically will combine. I say they typically do because sometimes they don't always. In that case, you have a negative 4x and a negative 35x. It's two negative numbers, so they technically get added together to be negative 39x plus 14. All right. We got a few more. Number 8. Now, what I like about number 8 is some of you can recognize this as it's the same term, except the only difference is one is positive and one is negative. So you might remember in algebra, I'm actually not sure if you learned this in algebra or algebra 2, but you will learn it at some point that these two terms are called conjugates of each other. And all that means is they're the same expression, except one has a positive sign, one has a negative sign in the middle. Everything else is the same. And typically they are always going to have the same effect at the end, which means that outer and inner part will always cancel each other out, and you're going to be left with basically a two-term expression. And if we FOIL it out, you'll see what I mean. We go through the FOIL, you get 2x times 2x, which is 4x squared. The outer, which is 2x minus 1, so it's minus 2x. But then the inner is 1x times positive 2x. So you're left with plus 2x. And then the last term is positive 1 into negative 1. You get negative 1. And the reason the conjugate is sometimes important is because these middle terms, like I said, if they're conjugates of each other, and you can recognize that they're conjugates, the middle terms always just cancel each other out. You have plus 2x minus 2x. They combine to 0, and you're left with 4x squared minus 1. There's nothing saying you need to necessarily remember that. For anyone going on to Algebra 2, and especially in calculus, we do use conjugates a lot in calculus. So they're definitely good to know. And that's what they are. You definitely will see them last year. Conjugation in both geometry and Spanish. Yes, different kind of conjugation though. And we'll do one more on this page. We'll just do I'll just jump to number 10. Number 10 just says 4x plus 3. But then they say square. So this is sometimes a hidden box method or hidden FOIL because think about when you're squaring something, what it means. It means you're multiplying the thing by itself. So it's really 4x plus 3 times 4x plus 3. So that's what that square means, and that's why you would need to do box method. The amount of people who would just write 16x squared plus 9, that's what a lot of people do. A lot of people want to just kind of distribute the square. You cannot do that. Squares do not work that way. So the answer is not going to be 16x squared plus 9. It's going to be slightly more complicated than that. Now we just need a terrible song parody about it. Ugh. Abby, if you want to create and sing that, be my guest. So we get 4x times 4x, which is 16x squared. And then the middle terms are usually the things that people miss because they kind of just distribute the square, which you shouldn't. But it's going to be plus 12x, plus 12x, plus 9. So the final answer should be 16x squared plus 24x plus 9. Which I think we reviewed some of this stuff at the beginning of the year, but I think it's important to just continue going over it. And like I said, all these skills, Algebra 2 is based on the fact that you have mastered these skills because you've learned them already in Algebra 1. So hopefully these aren't terribly difficult for anyone here. I am aware that you guys have all learned this before, but I think the refresher is good. Then we will do factoring. And now for factoring, I will factor the same way you guys do. I typically factor in a little bit of a different way. I know you guys write it out like this. 2 numbers that multiply, 2 numbers that add. So factoring is just going backwards. Factoring is literally FOILing, but going backwards. We're going to start with the expression, and we're going to factor it out into 2 expressions. So it's always 2 numbers that multiply into the C term. So if it helps you to you want 2 numbers that multiply into the 21, and then 2 numbers that add into the B term, which is this. And I'm calling it the B term because of the generic, ax squared plus bx plus c. Should recognize that form as a quadratic. And then for the A term, for all of these, we should note that the A term needs to be 1 for this method. You'll see that in 17 and 18 it is not 1, so we're going to have a different method for factoring them. But for all the other ones, they should be fine. Oh, number 16 also doesn't have a number in front of it. So we want 2 numbers that multiply, and they have to be the same number. So 2 numbers that multiply into 21 and then add into 10. everything is positive too, which is great, which is 7 and 3. 7 times 3 is 21. 7 plus 3 is 10. It's 21, 10, which is exactly what we got. That tells me the factors are 7 and 3. So how do we write that out? X plus 7, x plus 3. And anytime the symbol's right here, right, this might be something you may not have learned, but it's a little bit more advanced. If the two signs right here are, it's plus and plus, your factors will always be two positive numbers. It's kind of a good way to, help yourself out, that they'll both be positive. As we go to the next one, it's positive and negative. And another thing that might help you out, if it's positive and negative, you're going to have a factor. You're going to have one positive factor, one negative factor. Because the plus sign came first, the bigger number will be positive. Just a little trick to kind of help you out when you're trying to figure out these numbers, because sometimes the numbers are a little bit challenging to figure out. And our A term is 1, so we can factor like normal. So two numbers that multiply into negative 36. Two numbers that add into positive 16. And like I said, there's going to be a positive number, there's going to be a negative number. So I like to figure out the multiplication one first, because multiplication is kind of limited. You have 6 and 6, which is 36, but 6 plus 6 is not 16 or negative 16, so can't be that. So what do we have? Is it 12 and 3? No, I don't think 12 and 3 works. What about 4? Is it 4 and 9? 4 times 9? Nope. 18 and 2. I think 18 and 2 is going to work. 18 times 2 is 36. But like I said, the bigger number is going to be positive, and the smaller number is going to be negative, which is perfect, because if you look right down below, positive 18 plus negative 2 is positive 16. So those are our factors right there. So these get written as x plus 18, x minus 2. So sometimes it takes a little bit of trial to figure out, which two numbers are the correct ones to multiply together. And always be aware, there's a possibility that these two numbers that you're trying to think about don't actually exist, which you're going to have to then use another method. This is always the first method that you try. I know in algebra it works most of the time. Here in geometry it probably will work most of the time. I know in Algebra 2 and Calculus, they start to not work all the time, which means you need to kind of expand your methods on how to factor. But for our case, I think we're pretty fortunate that it's going to work most of the time. So then we get into 13. And again, I like looking at these symbols because the order of the symbols really help me. And minus plus actually tells me that both numbers are negative. Might have been something you've overlooked in the past, but it is always, the factors are always going to be two negative numbers because the sign is negative and a positive. And we'll see that when we start to factor. These numbers are starting to get a little bit bigger. But that's okay. Actually, let me share my calculator. Because now that the numbers get a little bit bigger, I like to kind of plug some stuff into a calculator and figure out, you could figure out all the multiples of, 96 and start kind of multiplying them together and figure out, what's going to add or subtract into negative 98. So I like to think about, what divides into 96 easily. I divided it by 4 because I know it was going to divide by 4, and I got 24, which is actually really good because 24 plus 4 is 28. So on my first guess, I think I found the factors. And like I said, they both should be negative because the symbols told me that they're going to be negative. So negative 4 and negative 24. Negative 4 times negative 24 is in fact positive 96. You can check that out. Negative 4 times negative 24 is positive 96. And then negative 4 plus negative 24 is in fact negative 28. So that those factors work out nicely. But it's always just good to break out a calculator, start dividing by, factors that is divisible by 96. You can divide it by 2, you can divide it by 4, and then you got to just start thinking, is it divisible by 3, 5, 6? You just start plugging in numbers, see what's dividing it by, and then see if those two numbers would add into the number that you want. All right. I think we got a pretty good idea on that. We're going to skip down. Oh, actually, nope. We will pick this up tomorrow because it is 11:41. So we'll stop right there. We will continue practicing tomorrow because I definitely want to practice some of the quadratics. But like I said, I'll put that weekly up on Google Classroom. But we're all set for today. I took an extra minute. I'm usually pretty good at not, but, sorry, there's no bell. But that's fine. Have a nice day, and I'll see you guys tomorrow. All right?